Hello and welcome to our today's lectures. We are going to discuss the topic surface tension. In these topics, now we have learned the viscosity can be determined by experimentally. You know that viscosity of liquid is generally measured with the help of the apparatus are called as Ostwald viscometers, which is based on the equation can be proposed by the name of the scientist viscosity to determine the coefficient of viscosity. This is designated as eta. So this eta is equal to pi p r square p into t upon 8L into p, where this p is the volume in cm cube of the liquid and flowing in it times t through a narrow tube having radius r in centimeter and length is a L centimeter. Under the pressure, head of the pressure P, which is measured in dynes per centimeter square. Eta is the coefficient of viscosity and they can be determined experimentally by using this Ostwald viscometer. In this method, the viscosity of given liquid can be compared with the known viscosity of the reference liquid, usually used as water. If this eta and eta 0 be the absolute viscosities of a solution and pure solvent respectively, having the time t and t0 up their corresponding flowing times, and therefore t is equal to 8 into Pl upon p pi r raised to 4 into eta. T0 is equal to 8 into Pl upon the p pi r raised to 4 bracket into eta 0 equation 4. For this given capillary, the quantities within bracket, that is this bracket, they will have same values and hence can divide the equation 3 to 4 we get. So this is t upon t0 is equal to, this will be cancelled. So eta upon eta 0 is equal to this eta r. The term eta upon eta 0, it is known as relative viscosity. But experimentally, we can measure the time flowing for the same volume we have given the liquid and the reference liquid as a water through the same capillary can be measured, and then the eta L and eta W, they will represent the viscosity of the given liquid and that of the water respectively. Therefore, we can measure the viscosity of the liquids and viscosity of reference liquid, that is the water, as like the eta L is equal to pi into PL r raised to 4 into TL upon 8 into LV. Eta W is equal to pi PW into r raised to 4 into TW upon 8 LV. For those terms, it will be cancelled as like this. So eta L upon eta W is equal to, this is PL into TL upon PW into TW. We can take an ease of formula. So for this TL is the time in second for flowing of the liquid. TW is the time in second for flowing of the water or the reference liquid. But you know that the formula pressure is equal to force upon area. This force is the mass into gravitations upon the area. You know that this mass into G, that is the density into, so volume into density into G upon the area, and therefore the pressure of the liquid PL is equal to V into density dl into G. and pressure of water Pw will be the capital V into dW into Z. Here this capital V will be same for this liquid water and water and liquid, and therefore pressure of both liquid they will be proportional to with respective density and the dW. Substituting these values on those equation we get eta L upon eta W is equal to, this is dL into dL upon dW into dW, and therefore we can measure the viscosity for those liquids, that is the eta L is equal to, modify those equation we get this TL upon TW into dL upon dW into eta W. Now we have measured viscosity of liquid by using this first order viscometer. First order viscometer are like this type of the measurements or this type of the apparatus. This apparatus is consist of a glass tubing which is attached to here. It is a glass bulb. It is a very small capillary fit into this tube, having other bulb which is smaller than this bulb, and this side of the tube is attached to one of the rubber tubing, so we can suck the liquid on this manner up to this mark. So this is type of the apparatus mainly used for measure the viscosity of various liquids. So it is a method to employ the use of apparatus called as a viscometer. It is a viscometer, but mostly commonly used viscometer as a Ostwald viscometer shown is here. So those viscometers they consist of capital A is a one of the bulb which is marked capital A, above the A1 and below A2, like this A1 to A2, which is attached a capillary tube. It is a very fine capillary tube is attached to here, and the storage bulb, it is a large bulb which is attached to here, capital C. A definite volume of the experimental liquid can introduce into this side of the glass tube and suck the above this liquid up to this mark A, and then the time required for the liquid, then open this and flowing this liquid to mark A1 to A2 to measure this time, and this viscometer is clean, dry and experiment repeated again and again using the other liquids, and hence by using this time in seconds we can measure the viscosity for those liquids, that is the eta L is equal to TL upon TW into dl upon dw. The densities we can measure for those other liquids, we can determine the viscosity into eta W. Next points, now we are going to discuss liquid crystals. You know that the milky and transparent anisotropic substances they produce before being transformed into a clear liquids, they have been named as a liquid crystals. Some characteristics are there for the liquid crystals. The first characteristics, it is a mesomorphic state between the crystalline and isotropic liquid. The formation of liquid crystal is very rare, but liquid crystal molecules are arrangement parallel to each other, and hence the possesses orientational or weak positional orders. They will results can flow like a liquid. The liquid crystal have fluidity of liquids and optical properties of the solid crystals. Now first type of the crystals, now we have seen this here, the nematic liquid crystals. Nematic liquid crystals, this means that it is in the phase the molecules lie together. It means if they will have all same directions, can lie, but it is staggered like cars on a B and BUG, sorry, busy multi-lane highway can be used such a class or such a type of liquid. Pneumatic liquids have transparent appearance because they scatter the light strongly, and therefore pneumatic liquid crystals can flow more readily than the smectic liquid crystals. For example, para-hydroxyanisole, para-hydroxyphenol, para-methoxycinnamic acids, anisaldezine, then dibenzyl benzidine. So these some of the examples for pneumatic liquid crystals having their melting points. Next type is a smectic phase. Smectic phase, they will be the molecules lie up like soldiers. You know that soldiers, the soldiers at this, the dress of the soldiers, so line will be there. So such a types of crystals, it may be formed on the parade and the form layers. The cell membranes are composed, it may be smectic liquid crystals. They do not flow is a normal liquid. For example, the ethyl para-azoxybenzoate, ethyl para-azoxycinnamate, para-octyl azoxycinnamate, and their melting points is here. And this is the transition temperatures. So these types of the smectic liquid which is there. Next is a cholesterol phase. In the cholesterol phase, the molecules form smectic-like layers, but the neighboring layer have molecules at slightly different angles, always turning in the same direction. See here, this is a type of cholesterol liquids. It means it's different angles, right? One direction, or other is other direction, or other is this direction. So all such a types of smectic, the cholesterol phase will be there and always turning in the same direction, going up to stack of layer of the other layer. And so the crystals have helical arrangement of the molecules. Now, classification of the liquid crystals on the basis of their mode of preparation. You know that thermoprotic liquid crystals. Thermoprotic liquid crystal, it means the transition between phase occurs due to temperature. Then the liquid crystals are called as thermotropic. Thermotropic crystals, it made by the melting the solid phase. The liquid crystal phase exists over a short temperature range between the solid and liquid state. For example, the para-hydroxyanisole is a thermotropic liquid crystal. Para-hydroxyanisole is a thermotropic liquid crystal. Used for this liquid crystal is a thermotropic crystal which is highly viscous and can be either transparent or opaque, and therefore they are used in applications as like the watches, computer screen, thermometers, but it mainly used for in technical application. Second type of liquid is a lytropic liquid crystals. So these crystals, it mainly layered structures. They will result the action of solvent on a solid. For example, aqueous solutions of detergents, liquid, and cell membrane. These are important for the biological systems. Now, we have seen some applications of these liquid crystals. First is the electronic displays can be made. So this use factor orientations of the molecules in the liquid crystals, changes in the presence of electrical field, but these orientations can cause change in their optical properties, making them opaque or transparent and hence forming the pattern on various electronic screen. Second type of liquid is cholesteric liquid crystal. They may be used in interest because the helical structures unwinds slightly, temperature is changed, but it is a twist of helical structures and hence is affect optical properties of the liquid crystal. And hence these properties with temperature these affect which are utilized in liquid crystals. Polymer dispersed liquid crystals. These polymer dispersed liquid crystals sheet, the rolls are used to adhesive wax smart film which can be applied to various windows and electronically switched between transparent and opaque to provide privacy. Next is a thin flat television or computer display can made was once considered impossible but now a part of our everyday ultra thin flexible computers, television displays, fast reacting thermostats can be made for these crystals because it is special kind of material and therefore it seems to be neither solid or nor liquid. Many common fluids are like soapy water, they can impact liquid crystals. Soap forms variety of liquid crystal phases depending on its concentration in water. Liquid crystals is tunable filter can be used as a electro-optical devices, for example, hyperspectral imaging. Thank you.